This is the Hints for S4 National 5 Homework 3. In question 1 we're asked to evaluate 6 to the power of minus 2 and 4 squared times 2 to the power of 4. This is going to give us a numerical answer, so in this first question we have to deal with the minus power. Okay, and when you have a minus power, that means we can move it to the bottom, make it a fraction, and it becomes a positive power. So 6 to the power of minus 2 can be rewritten as 1 over 6 squared. Okay, a negative power becomes positive on the denominator. You then have to work out what 6 squared is, and that will give you your answer. For part B, you're simply just doing 4 squared times 2 to the power of 4. So literally, whatever the answer is for 4 squared goes in there, and whatever the answer is for 2 to the power of 4 goes in there, and then you work out the answer from there, okay? So in question 2 we're looking to fully simplify the fractions. First fraction I've got here is I've got 3 and 2/3 times 1 and 6/11. Now I can't just multiply the 3 by the 1. What I have to do is I have to turn them top heavy. And I do that by multiplying the big number by the denominator and adding it to the top. So 3 and 2/3 can be rewritten as 11/3. Okay, I've been multiplying that by the top heavy fraction I can make from multiplying the 1 by 11 and adding it to the 6. So then, when you multiply fractions, we times the numerators, times the denominators, and fully simplify. For part B, I've got 10y over x divided by 2y over 3x. And now, because I can't divide by a fraction, I have to flip the second fraction and multiply. So the first fraction is the same, which is 10y over x. And I multiply the second one by 3x over 2y. Okay, so I flip the second fraction. Again, just times the top times the bottom, fully simplify. In question 3 we're looking to fully simplify the expression root 12 plus root 75 minus root 27. Now to do that I need to simplify all these surds and leave them in its simplest form. So I'll let you have a go at the second two. I'll show you how to do root 12. When we simplify surds we look for the highest square factor. Okay, so you think of all your factors of these three numbers and pick the highest square factor. So the highest square factor of 12 is 4, and that's paired with 3 because 4 times 3 is 12. So I can rewrite the square root of 12 as the square root of 4 times the square root of 3. The reason we pick this square factor is so that when I'm left with the square root of a square number, I get a nice whole number at the start. So root 12 simplifies down to 2 root 3. I'll let you have a go for root 75 and the square root of 27. Now we're looking to find the gradient of the y-intercept for the equation 6x minus 2y is equal to 4, and to do that we need to rearrange so that we have an equation in the form y equals mx plus c. Okay, so when we have it in that form we know that m is the gradient and that c is the y-intercept. Okay, so to do that we need to move this positive 6x over to the right hand side, and that will leave you with minus 2y is equal to something. Okay, you're then looking to find y, and you do that by dividing through by minus 2. Okay, so when you have y on its own you can get the gradient and the y-intercept from the equation. In question 5 you've got 3/4 brackets 2x minus 5 is equal to 6. Again, before you multiply out the brackets it's much easier to eliminate the fraction, so I can times both sides by 4, which means the 4 on the denominator will cancel, and I'll be left with 3 bracket 2x minus 5 is equal to 24. You can then multiply out the brackets and solve for x. In question 6 we're looking to factorise x squared minus 3x minus 10. So what we have here is we have a trinomial. Okay, and a trinomial is going to give us 2 brackets. Okay, so at the side of your page we'll draw a wee table. At the start of our brackets we're going to have 1x and 1x. We take the factors of the coefficient of x squared, and they go to the top of the table, and then inside your table go all the factors of 10. 1 and 10, 2 and 5. So we know that both the brackets are going to start with an x, and because it's a minus 10, we know the signs are going to be different. We then use our table to cross multiply and find the answer. For part B, we're looking to factorise both the numerator and the denominator. Now, if you haven't noticed already, your answer from part A is your numerator in part B. You then want to factorise part B and fully simplify. Question 7. We're looking to simplify the expression 4x to the power of 5 times 3x to the minus 2 all over 2x to the minus 5. So to start this off, we need to tidy up the numerator. When we're multiplying, we times the numbers at the front, and then I'll let you try and figure out the rules for the power. Okay, so it's going to be 12x to the power of something, and we're going to divide that by 2x to the power of minus 5. Okay, so think about what your rules are for when you multiply. What do you do with your powers? And then it's opposite when you divide. You divide the numbers at the front, and then you do the opposite of what you do with the powers when you're multiplying. In question 8, we're looking to complete the square for x squared minus 2x minus 5, writing it in the form x plus b squared plus q. Now, to get it in this form, our bracket's going to start off x, and we always half the term in front of the x here. Okay, so you take half a minus 2, and whatever that might be goes directly inside your bracket here. Okay, put a wee squared at the top of the bracket, and to get the number outside the bracket, we take whatever number we've got in here, square it, then what do you add or subtract to get to 5? Add or subtract to get to minus 5. Okay, so it's half your minus 2, whatever that is, square that number and think, right, what do I need to add or subtract to get to minus 5, and that's the number that goes outside. Okay, so that's the number that goes outside your bracket there. In question 9, we're told that 4 apples and 3 bananas cost £5.30, so I'll call that 4x plus 3y is equal to £5.30. Okay, so I'll let x be the apples, y be the bananas. I know that 3 apples and 2 bananas cost £3.80. So I'm looking to find out how much 5 apples and 9 bananas cost. I need to do this by solving the equations. So with simultaneous equations, I'll label them 1 and 2, and I always try to eliminate the y term. So I look to get the same coefficient in front of y. So I look for the lowest common multiple between 3 and 2, which is 6. So I can times my first equation by 2, second equation by 3, and solve from there. In question 10, we're told that Paul's summer holiday costs £894.40, and that includes a booking fee. Okay, so what's the price of holiday without the booking fee? If the booking fee is included in the holiday, it means it's adding an extra 4%, so that 104% of the total holiday price is costing £894.40. So it's a reverse percentage question. We were looking to find 100%. So what you want to do is you want to divide by your percentage to find 1%, then times by 100. So divide by 104 times by 100. In question 11, we're told that AC Milan is currently worth $856 million. The value of the club is depreciated by 9% in the last year. So what was the value of the club last year? Okay, so we know that it's depreciated by 9% to get to 856 million. So it's a similar style to question question 10, where we know that 9% less of your total value, which is 91%, is equal to 856 million. Okay, so again you're looking to find 1% and then rewrite your answer to find 100%. So 9% is what it's depreciated by. It's currently worth 856 million. Find 1%, find 100%. Don't forget to round your answer to 3 significant figures. You've done all the hard work up until then. Okay, so in question 12, we're told that the square has sides of 3 centimetres, and we've got an arc here that creates a petal on the inside, so we're looking to find the area of this petal. Okay, so what I need to do, I need to break my my shape into 2 parts. So the first thing I'd like to do is I'd like to break my shape up. So the first area I'd like to look at is a square. So hopefully by now we know the formula for the area of the square. Okay, I'll let you work that out yourself, and you want to figure out what the area of the square is. And then looking to find the area of the arc that's made with a petal. Okay, so I'm taking the outer edge of the petal along here, and I'm going to find the area of this arc here. So the formula you need for that is angle over 360 times pi r squared. Okay, so you find the area of the sector, which is angle over 360 times pi r squared. Now you should know the angle inside. I'll then would look to subtract my area of the square and my area of the sector. Okay, if I subtract the sector, I can then find this area in here. Okay, and if you go back to the original drawing, I have 2 of these areas. Okay, they're exactly the same size. So for me to find the area of the petal, I'm going to do the area of the square, take away 2 times whatever your answer is for the area of the square minus the area of the sector. Just to be easy and show you, I'm just going to call that y. Okay, so area of the square minus the area of the sector is going to give you an answer y. So to find your total answer, you're going to do the area of the square minus 2y. Okay, so 2 times that answer there, and that will give you the area of the petal. Okay, I hope this has helped.